When you lift your eyes to the night sky and behold the moon, that timeless, silvery sentinel, you are witnessing the outcome of one of the most enduring relationships in our solar system. The moon, Earth's closest neighbor, appears so constant, so unchanging, always showing the same familiar face. But this serene gaze masks a deep, dynamic history shaped by powerful forces acting over billions of years, a cosmic dance choreographed by gravity and time, known as tidal locking. To truly grasp this extraordinary phenomenon, we must journey back to the very beginning, to the chaotic crucible from which our solar system emerged. Over 4.5 billion years ago, the newborn sun's swirling disk of dust and gas was a tempest of collisions and accretions. Planets formed slowly from clouds of cosmic debris. Earth itself was a violent world of molten rock, reshaped repeatedly by impacts. Among the most cataclysmic was the collision with a Mars-sized protoplanet, Theia, a moment so powerful it melted the young Earth and blasted a vast cloud of debris into orbit. From this debris, under the slow but relentless pull of gravity, the Moon was born. Yet this newborn satellite was not the tranquil orb we see today. It spun rapidly and wildly, revealing all its faces to space with every orbit. The Earth, however, was exerting a powerful, invisible influence, its gravity tugging gently but persistently on the Moon's bulging mass, raising tidal bulges that flexed the Moon's interior and slowed its spin. This process, tidal friction, acted as a brake, steadily draining the Moon's rotational energy. Over tens of millions of years, the Moon's spin slowed until it synchronized perfectly with its orbit, a state known as synchronous rotation or tidal locking. From that moment, the Moon began to present the same hemisphere to Earth, as if frozen in a silent pose of cosmic intimacy. This state of tidal lock is far from a coincidence. It is a fundamental principle of celestial mechanics found across the universe. Many moons around other planets share this trait, including Jupiter's Galilean moons and Saturn's Titan. Tidal locking emerges naturally wherever gravitational forces between orbiting bodies create lasting, mutual influences. The process can take millions to billions of years, depending on the masses, distances, and internal properties of the bodies involved. On the Moon, tidal locking has left a geological signature. The near side, forever facing Earth, features vast basaltic plains, maria, that filled ancient impact basins with lava. The far side, hidden from our eyes until the age of spaceflight, is heavily cratered, mountainous, and ancient. The difference reflects how tidal forces affected the Moon's internal heating and volcanic activity, creating a permanent geological asymmetry. But the Moon's tidal lock is just one chapter in an ongoing story. Earth itself is caught in this gravitational dance. The Moon's gravity pulls on Earth's oceans, raising tides that rhythmically rise and fall, exerting friction on Earth's rotation. This friction gradually slows Earth's spin, lengthening our days over time. Hundreds of millions of years ago, a day on Earth was only about 6 hours long. Now, it stretches to 24 hours and will continue to grow longer, imperceptibly but inexorably. As Earth's rotation slows, the conservation of angular momentum demands that the Moon moves farther away, receding at roughly 4 centimeters per year. Though subtle, this drift has profound consequences over geological timescales, changing the dynamics of the Earth-Moon system and our planet's environment. The Moon also stabilizes Earth's axial tilt, the angle at which Earth spins relative to its orbit around the Sun. This tilt creates seasons, and regulates climate patterns. Without the moon's gravitational influence, Earth's tilt would vary chaotically, potentially causing severe climate swings that could threaten the development and survival of complex life. The consequences of tidal locking ripple far beyond mechanics and geology. They extend into the very fabric of human culture and consciousness. Since ancient times, humans have revered the moon, weaving myths and stories about its phases, light, and constancy. The locked face of the moon, always gazing down on Earth, has been a symbol of stability, guidance, and mystery. Lunar calendars have governed agriculture, navigation, and ritual. The moon's changing phases, visible only on its near side, have inspired art, poetry, and religion across countless cultures. The moon's far side remained a profound mystery until the dawn of the space age. In 1959, the Soviet Luna 3 spacecraft captured the first images, revealing a landscape starkly different from what Earthbound eyes had known. This revelation expanded humanity's understanding of our celestial companion and underscored the vastness of our ignorance, even about our nearest neighbor. In recent decades, human exploration has transformed the moon from myth to reality. The Apollo missions of the 1960s and 70s brought astronauts to the lunar surface, where they collected rocks, measured seismic activity, and planted flags. These missions illuminated the moon's origin, composition, and history, validating theories about its birth and tidal locking. They also laid the groundwork for future exploration and potential colonization. As we prepare to return to the moon in the coming decades, with ambitious plans for lunar bases and even permanent settlements, understanding tidal locking becomes more than academic. The moon's day lasts nearly 29.5 Earth days, meaning long periods of sunlight and darkness that pose challenges for human habitation. Temperature extremes, radiation, and gravity all interplay with tidal mechanics to create an environment both familiar and alien. Beyond Earth and Moon, tidal locking shapes planetary systems across the cosmos. In exoplanetary systems, tidal locking is common. Many potentially habitable worlds orbit close to their stars, locked in eternal day or night hemispheres. These conditions affect climate, atmosphere, and the possibility of life, influencing how we search for other worlds like our own. Tidal locking, therefore, is a universal theme, a fundamental cosmic rhythm that guides the evolution of worlds, the birth of landscapes, and the emergence of life. It is a force that connects the smallest moon to the largest planet, the ancient past to the distant future, and science to spirit. Philosophically, the moon's tidal lock invites us to reflect on the nature of connection and change. It reminds us that even the slowest, gentlest forces, gravity's invisible tug, time's endless flow, can create unbreakable bonds. That stability is born from dynamic balance. That permanence emerges through motion. In this locked dance, we see echoes of human relationships, of the universe's grand design, and of our place within it. When you next gaze at the moon's glowing face, consider the depth of its story, a tale written in stone and light, in motion and stillness, in silence and tides. This is the story of two worlds forever entwined, locked in a cosmic dance that continues to shape our lives, our planet, and the universe itself. The moon is not just a satellite. It is a partner in time and gravity, a symbol of endurance and harmony, a silent witness to the unfolding mystery of existence.